Okay, so for today's objective, we are going to solve more polynomial functions, but we're going to go a step further, and based on what you were taught on Monday, looking at the end behavior and how many intercepts you'd be looking for, we're going to ultimately focus on graphing these polynomial functions. All right? Now, the first slide here that I have for you looks at kind of the steps we're going to follow. You should notice a few things here. It puts it all lumped into one, the first step where it says to find the real zeros. All right, but again, that was a process that took us a long time when we were first doing these before Thanksgiving. Now, to kind of make the process a little bit simpler as we're learning this, we're going to focus today on only solving and graphing cubic polynomials. So that means they're going to have a degree of 3. So the highest power will be 3, so x cubed. Before we went on break for Thanksgiving, we actually spent a majority of our time solving quartic polynomials, so x to the 4th power. So hopefully that shift, where it'll be a little bit quicker, a little bit more efficient, will help us get to the main thing today, which is talking about graphing. All right? So let's go ahead and start by looking at an example. First thing I always do when I look at these problems is I want to know what it means when it says to solve. All right? Well, when we first started solving these, we talked about finding the roots. And there's a lot of different words you can use when you say solve. Whenever you're trying to solve a polynomial and you're trying to find the zeros or the roots, you're ultimately trying to find out what values for x would make it become 0. So kind of the first thing that I do is I write down x cubed plus 4x squared plus x minus 6 equals 0. I want to know the numbers out there that when I plug it in for x will make that whole thing become 0. And today, the step further that we're going to go is once we find those zeros, we're actually going to plot them and show you that those are the x-intercepts. So that's really the link that I want your brain to be thinking about. They make the function become 0, and on the graph, they are the x-intercepts. Okay? Now, when I look at this, this is a cubic polynomial with 4 terms. And I always, because it'll go faster, I always look to see, can I factor by grouping? And I told you guys this before Thanksgiving, that we might not be able to factor by grouping like we were on all of the problems previously. So when I look at the factors by grouping, the first two have x squared in common. So I'm going to take out x squared. And that's left with x plus 4 in the parentheses. Again, if you're confused and like, oh, I don't know how you did that, I divided x cubed and 4x squared divided by x squared, and that left me with x plus 4. But when I look at my other group, x minus 6, they don't have anything in common except for a positive 1. And if I factor out a positive 1, I get x minus 6 in the parentheses. And if you notice, right, the whole thing that we were looking at when we were doing this before break is that x plus 4 and x minus 6, the stuff in parentheses has to be the same if you're going to be able to continue solving using factor by grouping. So because it's not, I put a little note out here, unable to use factor by grouping. All right, but I want to just kind of urge you to try this every time. All right, every time try to try it because it will save you time in the long run if you are able to factor by grouping. Now, if you're unable to, like in this example, we are not able to. All right, that means we need to go back to something that we learned before break called the rational root theorem. Now, the rational root theorem at this point is where I'm looking for the numbers that I want to try to plug in and make that 0. All right? So if you forgot, we're looking at the constant and the leading coefficient. All right? The constant and the leading coefficient. So the constant of this polynomial is -6, and the leading coefficient is a positive 1. Okay? So we want to do factors of 6 Again, I know it's negative 6, but it really doesn't matter because we're going to use plus or minus for all of this. So we want factors of 6, which is plus or minus 1, 2, 3, and 6. And we want to divide those numbers by the factors of 1, which is 1 times 1. So we don't have to write it twice. So ultimately, the first number that I'm going to try in the corner is going to be a positive 1. And I hope that it makes the whole thing become 0. If it doesn't, then I'm going to move on to negative 1. And if that doesn't, then I keep going, and hopefully one of these will give me a root, a 0 in the remainder. Okay? So I'm going to go ahead and try 1 in the corner. So 1 in the corner. And I'm going to write down my coefficients from the original problem. The coefficients are 1, 4, 1, and negative 6. 1, 4, 1, and negative 6. And I'm hoping that I get 0 at the end of this. So again, we bring down the first 1, that's the coefficient. 1 times the 1 in the corner makes still 1. 4 plus 1 is 5. 5 times the 1 in the corner is 5. 1 and 5 make 6. 6 times 1 is 6, and negative 6 and 6 is 0. Awesome. So we were able to get a root. Okay, we're able to get a root here. Now, because we have a root, as we did before Thanksgiving, now all I care about are the numbers that are below that line in my synthetic substitution. So what I'm going to do is I'm going to copy all of this, all right? Copy all of this onto the next slide, all right? And I care about those numbers that are underneath, all right? So 1, 4, 1, negative 6, just copying my work from the last slide. All right, so we have 5, and then 6, and this was 0. Great. Now, I'm going to use 1, 5, and 6 to write down what is remaining from this original polynomial. Now, the original problem, if you look at the original problem, it was x cubed. So when I write down what is remaining, I always decrease that power by 1 to get x squared. So this is 1x squared plus 5x plus 6. That is multiplied, and this is probably one of the more challenging things to remember. Whatever you get as your root, that number gave me 0 at the end, I'm going to write that down as a factor, but I always want to think opposite. So the opposite of a positive 1 gives me x minus 1. That's still equal to 0. And I know this is a difficult thing for you guys to see, or can be challenging for our brains, but we actually still have the original polynomial. All right? If you distribute all of this out, you would still have x cubed plus 4x squared plus x minus 6, what we started with. Okay? I'm hoping that as you look at this, some of you might recognize that this first polynomial here is a quadratic trinomial, which we factored those in the month of October. So I'm going to write down 2 binomials to factor it. So I'm looking for factors of 6 that add to 5. So 2 numbers that multiply to give me 6 and also add to give me 5. And that's 2 times 3 is 6, and 2 plus 3 is 5. So those are the factors there. I bring down my x minus 1, and now I have fully factored this polynomial. So to finish this, I'm going to set each of them equal to 0. All right, so x plus 2 equals 0, x plus 3 equals 0, and x minus 1 equals 0. So the numbers that make those 0 are my roots. And when we graph them, these numbers are going to be the x-intercepts. All right? So again, at this point, before Thanksgiving, this is as far as we went. All right? All we did was we found the roots. But because we are now looking at the graphs of these, the curves, we want to make sure that we move into the graphing. So I went ahead and put a coordinate grid on the next slide. So I'm going to plot these 3 roots. All right? So we had positive 1. Remember, these are all x-intercepts. Positive 1, negative 2, and negative 3. So we have negative 2 and negative 3. Okay. Now, at this point, all right? Because it's not as easy as just like, okay, we're going to graph a parabola, because this is to the third power, right? When we did our graphing on Monday, looking at our end behavior, when it's an odd degree, 3 is an odd number, we're going to have one of them going up and one going down. And because it's positive, all right, because the leading coefficient is a positive one, we're going to make sure that we're starting at the bottom left, all right? So down over in this area, quadrant 3, right? This is quadrant 3. And we're going to finish in quadrant 1. All right, so we'll finish over here. That's how we know it's positive, going from bottom left to top right. If it was a negative one, right, if our leading coefficient was negative, then you'd be going from top left to bottom right, quadrant 2 to 4. All right, so now I always turn to my calculator, and I type this in using the table function, and I want to plot down some more points that I find. My y-intercept, so when x is 0, the point on the y-axis is -6. So down here, -6. I'm just looking for more points to plot. I see there's a point -1, -4. So I'm going to plot that. There's -1, -4. I've already plotted 1, 0. 2 is 20. So 220 is way off the grid, so I can't graph that. Well, let's see if I go to -3, or excuse me, -4. -4 is -10, so that's down at the very bottom here. And that is as many points as I can plot. So again, I know it doesn't really look like anything yet, but we're going to do our best to sketch. Now, I'm going to be honest, this is not going to be precise because I don't know how high to go and how low to go on some of these peaks. So I'll just show you what I mean. When I'm drawing it from bottom left to top right, when I go from the first x-intercept to the second one, I don't know how high to make this peak. So I don't know if that's supposed to go to 2 or 4. So I just guess. It's okay if it's not right. And then I go down and then finish again. This is 220, so it's going to be way off the grid. All right, and then make your arrows at the end. And that should look, as we talked about on Monday, like a cubic polynomial that has a positive leading coefficient going from bottom left to top right. So again, if you're thinking about the end behavior that we discussed on Monday, we would have as x approaches -infinity, so that means moving to the left on the x-axis, your function is going to be moving towards a -infinity, so f of x is moving to -infinity as well. So that's that arrow going down forever. And then if you look at up here to the right, as x approaches positive infinity, so as we move to the right of this graph, f of x is also approaching positive infinity in the y direction, going all the way up. All right? So I know there's a lot going on, and I understand that I'm not here to help you as you move through this for today, but don't worry. I will be back later this week, so we will go through this and make sure that you understand it. But really the main thing is solving like you've done before. Try grouping, try to factor by grouping with these first two, right? Try to factor them by grouping. One of them you will be able to, but the other you won't. If you are unable to use factor by grouping, you could, or you just, you're having trouble with it, you could always start with the rational root theorem and start going through to find your roots. And ultimately, you want to find 3 roots. Both of these are cubic. You want to find 3 roots, graph them on the x-axis, graph the y-intercept, any more points you can, and then try to make your sketch as best you can. All right, so good luck. I'm going to let you guys stay seated. Again, you should be listening to this on your own. Stay seated. Try them on your own. Look at my video again to see what I did and how to graph it. Use that calculator.